Hi, thank you for joining us on our virtual field day. I'm Rhonda Miller, and I'm here to talk about our project looking at nutrient cycling. If you'll come with me, we'll go look and see what we've been doing. So here we're out at our bars and little skinny strips to accommodate and match up with the zero tension lysimeters that we have out here. But we have the different breeds out here. We're looking at the nutrient cycling in the grazing system. We're interested in how both the grasses and the grasses with the birch-foot trefoil, a legume that contains tannin, react and how well they utilize the nitrogen, how much is lost either through leaching or volatilization. We're trying to find the most efficient and environmentally friendly system that we can. Now you might be wondering why we're worried about nutrients in a grazing system, because you say, the cows are just out there, they're eating it, it's just recycled back onto the pasture. That's true, except that within 1 year, the cows eat that grass from across the whole pasture, and then they deposit it in urine and fecal samples, but only about 10% of that paddock is actually covered or receives urine or feces in any given year. They also tend to kind of concentrate around the water troughs, so there'll be extra urine and fecal spots by the water troughs, and so that those nutrients aren't recycled uniformly back across the pasture. Especially for the urine. Urine itself is very concentrated. It's primarily urea, which rapidly converts to ammonia. But within the actual urine spot, that urine is contributing nitrogen in the amount of approximately 1,000 pounds of nitrogen per acre in that one little spot. Now, most of the paddock isn't getting that much, but that urine spot is. 1,000 pounds of nitrogen per acre is way too much for most of our plants. Most of that's either going to be volatilized and lost as ammonia, or it's going to end up leaching through the system and getting into our groundwater. And so that's what we're trying to find, is we want plants that will intercept that nitrogen and utilize it before it is lost either to volatilization or leaching. And here we are by our trailer. This is kind of our heart of our leachate collection, at least for the zero tension lysimeters. Inside you'll see a bunch of tubes and bottles, and there's little knobs on the wall. We actually have out in the field what are called zero tension lysimeters. They're 15-inch diameter by 44-inch deep soil core that we extracted, pulled out. We put then a reducer and cap system on it, put it in on stand, buried that back down into the ground where it was, and then we have PEX tubing running 6 foot underneath the ground all the way up to the trailer from various locations out in the field. The zero tension lysimeters are really helpful in that we can collect leachate year-round. So even if we can't get out here to collect it, the reservoir system is big, and so it has a lot of capacity. So as we get snowmelt, is a time when we see a lot of nutrients being flushed through the system, we can collect that snowmelt as it goes through that soil profile and what would normally go into the groundwater table. And we're interested in this because we want to look at the nutrients and the nitrogen and what happens to it. Nitrogen that goes past the root zone and into the groundwater actually can create human health problems. If you have too many nitrates in the groundwater system, it can cause or result in blue baby syndrome, which can actually be fatal in certain cases. And so we want to try and keep the nitrates out of the groundwater. The other point is that for the producers, if we have nitrogen that's being lost through the leachate, that's extremely expensive. It's nitrogen that's just wasted. And if you're buying fertilizer, it's costing you money because that's nitrogen that your plants could have utilized. Even if your plants are producing it, if it's a legume, you're flushing that nitrogen out. Those plants could have utilized that. So we're trying to prevent that. We're trying to find grasses or grass legume mixtures that utilize those nutrients very efficiently and have very few environmental impacts. Here we're out by one of our suction cup lysimeters. We have these lovely little metal covers on top of actually an irrigation cover. We don't think this is strong enough in case any of the heifers ever step on it. That's why I have the metal plates over it. And then down inside we have our suction cup tubes, so we can see the top of it with the rubber stopper and our little black access port. We then open that up, drop a little tiny tube down it, put a vacuum on it, suck out the leachate. We then put another vacuum back on the whole tube, close it, and then that vacuum over the week, the next week, slowly pull some of that soil water, the leachate, in through the ceramic cap down at the very bottom of the suction cup tube, and that's how we collect our leachate on the suction cups. Here we're at one of our root tubes out in the paddocks. We have these cages built around the root tubes to protect them from the heifers. They do like to rub against things, and we don't want them stepping on them and breaking them. The root tubes themselves, we actually have 2 in each cage, and they have a clear acrylic tube. They have a top, the black styrofoam in there, or like a rubber noodle, is to help keep light from intercepting. We actually take those out. We drop a scanner down there. We have a little round scanner, and it does 1-foot segments. We scan those roots, and then later on we'll go back, we'll take them to the lab, and we'll actually start tracing those roots, and so we can measure the root length, the root diameter. We really think that the root structure will probably help explain a lot of what we're seeing with the nitrogen leaching in the different forages, in the grass legume mixtures. We have 2 of these little tubes in each cage, and then we have cages scattered across the field. Now we've seen how we collect our samples and talked about the data that we're collecting. So what are we finding? As we look at the difference between the monocultures and the grass legume mixtures, we are actually finding that our monocultures leach more nitrogen than the grass legume mixtures. Now, in a standard conventional system, this would not be surprising at all. A lot more nitrogen fertilizer is added to the monocultures than what is being added in this system, which is an organic system. So in this case, our forages with the grass legume mixture have a much higher protein content, and therefore a much higher nitrogen content that's being recycled back onto the pasture. We are seeing this in the urine and the feces that we collect from the heifers and analyze. The heifers that are on the grass legume mixtures have much higher urea concentration and a much higher nitrogen content in the feces than what we are seeing with the ones that are on the grass monoculture. So even so, we're still seeing more nutrient loss with the grass monoculture. Most likely this is due to the difference of having one species, one rooting system versus 2. There will also be different microbes that can grow it with those different rooting systems, and the different microbes can also intercept and utilize that nitrogen. As we look at the actual grasses, we see that tall fescue, whether alone or with bird's foot trefoil, exhibits the least nitrogen loss, has the best interception utilization of any of the grasses that we're studying. That's been true throughout all of the studies I've conducted with tall fescue. It is always the best at utilizing that nitrogen. Perennial rye was the worst in this study, followed by meadow brome. Orchard grass actually did pretty well in this study. That is not what I've seen in some of the other studies that I've done. When I've looked at orchard grass in a conventional system and on a clay soil versus a sandy soil, orchard grass actually exhibited a lot of nutrient loss. So I'm really looking forward to the root scans on this part to see if the rooting system, if the orchard grass roots grow better in the sandy soil, or if we can figure out why we're seeing such a difference between this study and some of the other studies. And when we look at the individual treatments, again, the grass species tends to explain most everything that we're seeing. We have animal scientists on this project that are actually specifically looking at the reproduction and the heifer growth and the reproduction rates that we're seeing. The rationale for that is that as we add more nitrogen into the forage, that we expect to see higher blood urea nitrogen levels. That can impact some of the hormones and the reproduction rates. And so we wanted to monitor that and make sure that we weren't creating some negative impacts by adding the legumes into the system. So I'll show a small clip from clay isom.
Hi, my name's Clay Isom. I'm an associate professor in the Department of Animal, Dairy, and Veterinary Science. We're looking at the effect that different forage types have on the growth, development, reproductive performance, and health of dairy heifers. We're really interested to see how the animals respond to these different forage treatments. The entire purpose behind this is to help make dairy heifer development a more economically sustainable process for dairy producers in our region. In addition to looking at gross measurements of body frame growth, body weight gain, and other measurements that we can easily take from the animals. We also collect samples from these animals to look at things like parasite load, and we also collect blood samples so that we can look at internal biomarkers of growth and performance, different hormones that might be impacted by the different forages and the different growth conditions that these animals are experiencing. We wanted to make sure that we weren't compromising their future production potential, and specifically from my standpoint, I was really interested in understanding whether these animals would reproduce at the same rate as those that were conventionally fed in a feedlot type setting. And it was really intriguing to us to see that as we put these animals out on pasture, tried to push them hard with the different forage combinations that they were experiencing. We are able to achieve exactly the same conception rates and reproductive performance in the animals on pasture as in a feedlot setting, and that was satisfying to us. That we knew that we could push these animals hard, see good rates of gain and growth in these animals, and not compromise their reproductive performance.